In this video, I'll share some model construction techniques used for the Wright Brothers' first airplane. These are not suggestions in the model instructions. On November 17, 1903, the Wright brothers made their historic first powered flight. This accurate model is mounted on the ceiling in my man cave, along with 8 other model planes, most from World War II. This 1/16 scale kit by Model Airways is an accurate detail replica of the Wright brothers' first airplane. The manufacturer indicates it's for 15-year-olds and up. It's a challenging model to assemble. Hopefully this video will avoid some construction frustration. If you're going to spend time required for the build, watching this video is well worth the effort. The laser cut wood parts are excellent. The metal parts will also well detailed, but need some modest finishing. The 28-page instructions are good, but not simple to follow. It's worth downloading a PDF from the net so part numbers can be searched. Full model scale plans are provided and are used during construction. One suggestion provided by another builder is to measure, group, and label the wood strips. I found this was helpful. Another recommendation by someone who built the model is to Google pictures of the model and paintings or sketches of the Wright brothers plane. They can be referenced during construction. After putting the top wing paper plan on a board that accepts straight pins, you're ready to construct the wing building fixture. Half-inch foam insulation was used to hold this 35-inch wide plan. The wing fixture is assembled with glue and epoxy. 5-minute epoxy or quickset epoxy was used for much of the model joining. UV activated plastic was also found to be a very useful joining technique. While holding a part in one hand, just shine the UV light for 10 to 15 seconds to set the adhesive. A reinforcement wood strip was epoxied under each wing fixture splice for added strength. The finished wing fixture is ready to accept the 2 main wing spars. The instructions say to select the spar pieces so that they bend slightly downward. Found that most of the pieces were very straight. Those that were slightly bent were marked on the convex side with a small pencil dot. To slightly bend the others, clamp the pieces together, weighted the ends over a center support, and sprayed lightly with water. The next day, they were all bent sufficiently. I epoxy the brass hinge plates to the spar sections to be joined before putting a small amount of epoxy in the joint. So the clothespin used to hold the brass hinge plate to the spar did not stick. The clamping face was coated with petroleum jelly. The petroleum jelly technique worked well for much of the construction. To avoid the spar splice and the rib to spar glue joints from sticking to the wing fixture, it was brushed with a heavy layer. So the spar joints remained aligned while the epoxy cured. Clothespins were weighted with large metal clips. 2 sets of 38 ribs are needed to be joined to the spars. I found a drop of epoxy placed on both rib ends with a toothpick worked well for this first group. The epoxy started to thicken in about 4 minutes, so if a rib started to tilt from position, it could be righted. Only about 6 ribs were done at one time. The epoxy is viscous, so it helps hold the ribs in place without support. After about 10 minutes, the next batch of 6 ribs was started to be put in place. Made a small fixture from scrap wood to support the 2 short ribs at the wing ends while the epoxy cured. Attach the trailing edge wire starting in the center and just using the weight of clothespins to apply downward pressure. Put a drop of epoxy in the groove in the rib end. Bend the edge of the trailing edge wire and use petroleum-coated face clothespin to secure it to the wingtip. Use epoxy and let it dry overnight to provide a good strong bond. Then cut the excess wire. When finished joining all the ribs, remove the assembly from the fixture. I turn the wing over and after wetting the end of a toothpick with epoxy, spread it on the sides of each rib joint, making a small fillet. This provides the final secure joint. Remove the brass strut fittings and strut plates by bending back and forth. This will cause the connection to work harden and break. To join the strut fittings to the strut plate, super glue was tried, but found a better approach was to dip the toothpick in petroleum jelly, insert it firmly in the fitting. Then dip the fitting bottom edge into epoxy and laid it with its toothpick support on a plate. Did about 6 at a time. A total of 18 are needed. Note, use both small pieces of wax paper and aluminum foil for mixing the epoxy. Found the foil was best. The strut plates are epoxy to the spars to the bottom of the top wing and to the top of the bottom wing. The locations are identified as dots on Plan 1 and 2. Wood glue was used to join parts of the wing assembly jig together. A piece of 30 thousandths welding wire was placed in the pre-drilled holes to keep parts aligned. The assembled end wing jig parts are epoxied together. Note petroleum jelly was coated on the wax paper where the joint sections were placed so they did not stick to the paper. If the joint section was to be attached to another in a subsequent step, petroleum jelly was cleaned with rubbing alcohol. After making the side fixture pieces, join them together so that the lower height sections of each are towards the outside. This causes the downward bend of the wing. Although 2 small epoxy tubes are visible in this picture, a large tube from Harbor Freight is worth the extra cost. This is only a fixture, so to assure that the center butt joints are strong enough, a cover piece was made from scrap wood and epoxied in place. To hold the sections in alignment as the epoxy hardened, containers were placed on either end. The final joints were placed in compression by placing the assembly vertically and weighting with a petroleum jelly container. Assembly of the motor is straightforward. Some filing is required. The small tail file was used to enlarge the gear hole. There should be 2 small gears on the motor and large gears on the propellers. Caught the error too late to fix it. To make the required 18 wing struts that hold the top and bottom wing together, a simple fixture was fabricated. That helped produce 9 in each of 2 batches. Epoxy the brass wing strut eyes to the wood struts. Suggest filing or grinding a flat on the wing strut eye end before or after assembly. It is needed to have them slip more easily into the wing strut fitting. Complete the many small parts that are required. Epoxy the propeller supports to the wings. It is made from a flexible material and was bent with slight pressure for proper alignment. The wing struts are inserted in top and bottom brass strut fittings and epoxied in place. The aluminum tube supplied was not sufficiently long to use as the chain guide supports, so cut a small piece of tubing and epoxy those to the brass tube supplied. That worked well. Epoxy the chain guide support to the tube, using a clothespin to hold it. The instructions say installing the chain is the most difficult construction step. There are actually many of those. Use their suggestion of putting a small amount of superglue on a section of the chain end. After it hardened, use UV activated plastic to attach that end into the recess in the chain guard. The UV activated plastic was very useful for a number of joints. This relatively new product is seen on TV, but a larger size was purchased from Amazon. Made pulleys and used clay to hold while the epoxy cured. Wing wrapping control handles attached to the pulley shafts. Use 12-pound braided fishing line for wing wrapping cables. Tension the cables with clamps over the pulleys, then use superglue to join the two. Thicker, no-drip superglue works best. Follow the instructions and install wing rigging only where indicated. Pull taut and apply superglue. Note the center sections are the only ones where the wing rigging cables cross from front to back. The end sections must flex for wing warping control. Finally, the wings can be released from the fixture. Use the elevator plan and cover it with Vaseline wax paper so epoxy doesn't stick to the areas where the ribs are glued to the perimeter. Also assemble 3 operating struts to lever arm. Epoxy only the 3 operating struts and lever arm assemblies to support the bottom and top elevator parts. After that is cured, then add the 6 other vertical struts. Next, assemble the rudder per the plan. Then fabricate the landing skid and attach the landing skid and lower outriggers to the rudder. Finally, attach the upper outrigger struts to the rudder. The finished model looks fine. May not be as detailed or as neat as some will make it, but for my purposes, it does just what is desired. Hopefully some of the tips, for example the use of UV activated plastic joining and petroleum jelly, are useful. Read the manual several times from cover to cover before starting, and get a PDF version from the internet so you can do a part number search when needed. My display of plane models and World War II engine parts started with the purchase of a single exhaust valve from a World War II Pratt & Whitney R2800 18-cylinder radial engine. Found a cylinder and other parts on eBay and a source for NOS intake and exhaust valves in their boxes. Had a professor who worked for Curtiss Wright on radial engine development. Amazing how they were able to increase power by 50% from the start to the end of the war. My man cave has the airplanes that used these powerful radial engines during the war, as well as other hobby trophies, like these two 11 and 12-pound bass. My man cave is also where the office is located, in my 30-year-old exercise equipment. No excuse when it's there where I spend a lot of my time. My 7-day-a-week routine includes 3 sets of 10 pull-ups on back day. Not bad for 73. My main hobby is cars. After an old friend with 40 vintage race cars died unexpectedly 6 years ago, I started a model car collection. Now have over 40, and several are the Maserati birdcage that he owned and raced. If you're a hobbyist, you may have a MIG welder. That's my welder next to my Pro Street Rod in my garage workshop. We have a patented product that can help make better quality welds while cutting shielding gas cost in half. The system is called the Gas Saver System, and there are thousands being used by home hobbyists. The gas blast you hear at every weld start pulls air into the shielding gas stream, creating excess spatter in irregular shaped welds. It also wastes over half of the gas being used. Our patented product reduces the volume of this excess gas by 80 to 85%. It does that using a small ID large OD custom extruded gas delivery hose. In addition to the small ID, it has a peak flow limiting orifice in the hose fitting to reduce the gas surge velocity, avoiding excess turbulence. The product is inexpensive and it's very easy to install. Just replace the existing gas delivery hose. Over 10,000 are in use, saving fabricators millions of dollars annually. This simple custom extruded hose just replaces the existing delivery hose. Pressure is maintained to deliver a small amount of gas to purge the weld start area of air. There are no moving parts to wear or extra knobs to set. Visit our website, netwelding.com, for details. If you'd like a PDF of this presentation with text, it's available as a free download on this page of our website. Won't be easy to find unless you use the extension shown, as it has several hobbies on one page. Thanks for watching.